All right, guys, so video number 3. This time, rather than talk about something that you've already learned to factor and just sort of beefing it up from an x squared problem to an x to the third or x to the fourth problem, we're going to talk about something that you've never factored before, because these have to be x cubed or higher problems, and we're just now starting this. All right, so it's called factoring a sum or a difference, meaning you can have a plus or a minus sign of two perfect cubes. So what do I mean by the perfect cubes? Well, a perfect cube is like 1 cubed, which is 1 times 1 times 1 equals 1. 2 cubed is 2 times 2 times 2 equals 8. 3 cubed is 3 times 3 times 3 equals 27. 4 cubed, 64. 5 cubed, 125. 6 cubed, 216. 7 cubed, 343. 8 cubed, 512, 9 cubed, 729, 10 cubed, 1000. Now, I mean, you could go on and find more and more perfect cubes, but generally, I think these are the numbers that they would expect you to recognize that would be reasonable to put on some sort of assessment where you didn't get to use calculators. So familiarize yourself with your perfect cubes just like you've done with your perfect squares. And sometimes it's good to have a list right in front of you when you're doing the work. So you might want to have one list on your paper for perfect squares and a shorter list beside it for perfect cubes, just because it'll make you move faster. All right. So if I look at a sum of perfect cubes, it means I'm doing sum a cubed plus sum b cubed. So I'm going to give you the simplest rules here. The blue doesn't come in quite as clearly, so I'll change my color on the next board. And what you do is say, well, it's just two terms. It's a sum. Both are perfect cubes. So the formula is a plus b times a squared minus ab plus b squared. Notice if this is a plus, you lead with a plus. We're going to get down to a memory trick that I call SOAP. If I said a cubed minus b cubed, it's the exact same structure, but instead of a plus b, it's a minus b. So the sign in the original problem matches the sign in the first set of parentheses, or in the binomial. Now, your second set of parentheses is a trinomial. So it's a squared. Instead of minus ab, it's plus ab, but it's going to be plus b squared. So the sign pattern is SOAP. S stands for same. The first sign is the same as in the original problem. O stands for opposite. The second sign is opposite the first. The second sign is opposite the first. It's also opposite what you're given. The last two, AP, which I'm partial to, see if you understand why I'm saying that, stands for always positive, meaning the third sign is always positive, okay? So same, opposite, always positive. Now, the whole thing I use is bi, tri, SOAP. So that reminds you that you set up a binomial and then a trinomial, and then you use SOAP to set your signs up. So here's what you've got to know. Whether you use a plus or a minus b, the letter parts are the same. So it's the cube root and the cube root. And then you say this first one squared. Then you say first times second. Then you say the second one squared. And it is some memorization. We'll talk about why it works on the next problem. But you do need to memorize bi, tri, SOAP. And you need to memorize cube root, first squared, first times second, second squared. So we're going to go through the problems. Let's go ahead and do our first little example. We're going to do a few more examples on this since it's brand new to you. So example number 1, we're going to have just a simple x cubed plus 8. Okay, so x cubed is a perfect cube. 8 cubed is 2 times 2 times 2. So it's a perfect cube. It was on the list I just showed you. So I know it's going to be bi-tri-SOAP. So I'm going to set up my binomial and my trinomial. All right. The cube root of x cubed is just x because it's x times x times x gives you x cubed. The cube root of 8, we've already mentioned, is 2. All right. We also use SOAP. So same, opposite, always positive. Okay. Now, to get this first spot, you need to do first squared. So it would be x squared. In the middle, it's first times second. So x times 2, 2x. On the end, it's second squared. So 2 squared, 4. Guys, this trinomial does not factor again. So you're done. Now, let's go to a second problem that's also pretty easy, pretty straightforward while you're learning. So x cubed minus 125. So this time, it's still, x cubed is still a perfect cube. It's x times x times x. 125 is a perfect cube because it's 5 times 5 times 5. It doesn't matter whether it's plus or minus. I can factor both. So I'm going to set up with bi, tri, SOAP. SOAP is same, opposite, and always positive. So cube root of x cubed, cube root of 125. First squared is x squared. This one, first times second. So x times 5 is 5x. Don't worry about the negative. We already know the sign's positive. And then here, it's second squared. So 5 times 5, 25. So when I'm doing first squared, first times second, second squared, I'm looking at them without sign. I've already got the signs figured out. Again, this trinomial does not factor again, so you don't have to worry about that part. So why does this work? Well, let's multiply out one of the two. Let's multiply out this one because I've got the room to do so on the board. So remember, if I'm going to multiply this out, I do x times 1, 2, 3, and then I do negative 5 times 1, 2, 3. So let's watch that happen. So x times first is x cubed. X times second is plus 5x squared. Oops. X times third is plus 25x. Now I'm going to do negative 5 times first, which is negative 5x squared, and I'm going to stack them. Negative 5 times second would be negative 25x, and I'm going to stack them. And negative 5 times third would be negative 125. So when you add them, I get x cubed on the first column. These cancel on the second column. These cancel on the third column. And it's negative 125 on the fourth column. So x cubed minus 125 is what I get. So why does this factoring pattern work? Because when you multiply it back out, you get what you started with. But this factoring pattern is some memorization. So be prepared to get a jingle, bi-tri-SOAP, and then first squared, first times second, second squared, done. That's the way I remember it. That's what I sing in my head. So now let's go with another one. The number part's not going to be difficult. You may feel a little more frustrated with the letter part, but let's practice it. All right, do you remember when I said x to any even power is a perfect square? The reason is if you've got an even number, it's divisible by 2. So if you start out with like x to the 10th, the square root of this is x to the 5th, all right, because I divided 10 by 2. Or if you start out with x to the 50th, the square root is x to the 25th because I divided 50 by 2, all right? The same way you've got a rule like that for perfect squares. If you have x to any exponent that 3 goes into evenly, it's a perfect cube. So consider like x to the 12th. Well, what's 12 divided by 3? 4. So the perfect cube would be x to the 4th. And if you don't believe me, We know, oops, it's a perfect cube if I multiply it by itself 3 times in a row and I get back to what I started with. Well, sure enough, 4 plus 4 plus 4 adds up to 12. So this would be x to the 12th when I multiply it back out. So something like x to the 27th is a perfect cube because 27 is divisible by 3. It would be x to the 9th. And sure enough, if I cube x to the 9th, I get back to x to the 27th. So I have a difference. One's both a perfect square and a perfect cube, so the problem could go in either way. But when I see 27, I know 27's not a perfect square. It is a perfect cube. So now I'm thinking this is a perfect cubes problem. X to the 15th is a perfect cube because 15 is divisible by 3. So I'm going to do by, try, soap. Soap, same, opposite, always positive. All right. What is the cube root of 27? 3. What's the cube root of x to the 15th? Divide the 15 by 3, get 5. What's the cube root of 1? 1. So now I've got to do here first squared. So take your 3x to the 5th and square it. That gives you 9x to the 10th. Now, in the middle, we've got first times second. So 3x to the 5th times 1 is just 3x to the 5th. In your last slot, it's second squared, and 1 times 1 is just 1. The trinomial doesn't go again, you're done. Now we've done some straightforward problems. Let's start to blend, okay? So when I say blend, go back to the rule. You always start with GCF. So I look at this, and sure enough, I see that 5 will go into 320. So I know that 5 should be my number GCF. I have an x to the 10th and an x, which means I need to pull out the x. Now what I've got is 1x to the 9th, because that would multiply back out and give you 5x to the 10th. 320 divided by 5 is 64. So 5x times 64 is 320x. Now I look at this and go, oh wow, there's 2 terms. It's a difference, and my natural inclination is to think difference of squares. You should always check the thing that's most familiar first. Well, 64 is a perfect square, but x to the 9th isn't, so this is not perfect squares. Now wait a minute, is it perfect cubes? Yes, 64 is 4 cubed. It's 4 times 4 times 4, so this is a perfect cube. X to the 9th is a perfect cube because 9's divisible by 3. So that means I have to take this part and expand it into by, try, soap. Same, opposite, always positive. All right, so what is the cube root of x to the 9th? Divide the 9 by 3 and get 3. And we said the cube root of 64 is 4, okay? Now on the first spot, I need to square x to the 3rd. What is x to the 3rd squared? X to the 6th. In the middle spot, I need to say first times second. So x cubed times 4, 4x cubed. In the last spot, I need to square the 4, 16. And I'm done. That's it. All right. So on this one, I'm just getting wild and woolly with you. Look, I got all kinds of letters everywhere. Okay. So I look at it, and 216 and 343 seem familiar. Are they perfect squares? No, they're perfect cubes. This is 6 cubed. This is 7 cubed. And you would not recognize that if you don't try to memorize your perfect cubes. So you might even want to get your mom or your dad or a brother or a sister to quiz you on the perfect cubes. So if they say, what's 5 cubed? You say 125. Or they'll say, what's the cube root of 729? You say 9. Like practice those 10 until they come just like that for you. X to the 6th is a perfect cube because 6 is divisible by 3. 33, ditto. 33 divided by 3 is 11. 3, ditto. That's more obvious. So here we go. I'm going to do a little buy, try, soap action. I'm going to spread these out because I got more letters to fill in. Same, opposite, always positive. 216 is 6. The cube root of x to the 6th divided by 3, x squared. The cube root of y to the 33rd divided by 3, y to the 11th. The cube root of 343, we've mentioned, was 7. The cube root of z cubed, just z to the 1st. So I don't need quite as much room on that first one. All right, now I need to do first squared. So what is 6x squared y to the 11th squared? Well, 6 squared is 36. X squared squared, x to the 4th, multiply those exponents. Y to the 11th squared, y to the 22nd. Now we've got to do first times second. So first times second. So 6 times 7, 42. And then it's just going to be x squared, y to the 11th, z. I didn't space them out quite far enough, did I? Now here, I've got to do second squared, 7z times 7z, 49, z squared. We got one more problem. All right, I'm throwing a big one at you guys. So on the last one, let's start factoring. It's got 2 terms. I noticed there is no GCF, so I checked that off in my mind. And I'm thinking 2 terms. Well, it could be a difference. Like I know that with 2 terms, you can either have a difference of perfect squares or a difference of perfect cubes. And this is my little geometry, little icons to remind myself. Well, guys, in general, you need to do what you learned first, which was difference of perfect squares. So x to the 6th is a perfect square. It's also a perfect cube. And then you got a difference, so that could go either with perfect squares or perfect cubes. And one's both a perfect square and a perfect cube. So this one, I can do both. Again, do what you learned first. Difference of perfect squares should be your first try, okay? So if I do that, difference of perfect squares is when I do 1 plus 1 minus. 1 is 1 times 1. Now, if I take the perfect squares, I need the square root, which means divide the exponent by 2. So it'd be x cubed, x cubed. Now notice you have your difference of perfect cubes. So you're going to go again. So the first one, I'm going to go by try soap. X cubed is x times x times x. 1 is 1 times 1 times 1. Same, opposite, always positive. First squared is x squared. First times second is 1x. Second squared is 1 squared. Now go again. This is also perfect cubes. So by, try, soap. Okay. The cube root of x cubed is again x. The cube root of 1 cubed is again 1. First squared. First times second. Second squared. Now you're done. So that little problem really exploded on us. You're ready for the third part of MML. And if I'm remembering, I think it's 18 to 24.